Welcome to section 4, function parameters and ownership. In this section, we're going to take a look at ownership semantics implied by types, std string and std string view, owning classes and view classes, a generalization. std string. In this video, we're going to take a look at a reminder of what std string is, the semantics of std string, and the meaning of std string in interfaces. You might be asking, why are we covering std string again? Everyone should be more or less familiar with std string and how it is used. However, std string and the upcoming std string view introduced in C++17 are great examples of classes that have a similar interface but completely different semantics. We can use them to intuitively understand the difference between owning semantics and non-owning semantics for similar interfaces. Here's a reminder of what std string is. It is an owning wrapper over a contiguous char buffer. The buffer can be in place inside the string thanks to something called the small buffer optimization, often abbreviated as SBO, or dynamically allocated on the heap if the string is not short enough. std string has value semantics. This means that you can copy and move a string and it will not reference the same string in memory, but instead copy over every character and behave as a new value. It can also be constructed from const char star. This copies the characters into the buffer contained inside a std string, and it's a potentially expensive operation. Here's an example of a std string in use. In this case, we're instantiating a new string called s0, which is initialized from a string literal that says hello world. The type of the string literal is const char star. This means that all the characters will have to be copied either in the internal small buffer of a std string, or an allocation will be required and the characters will be copied on the heap. After the string is constructed, it takes ownership of this new buffer containing the hello world string. Now we can create a copy of the string. In this case, the copy is called s1 by copy constructing from s0. This will create a new string by copying every character from s0 to s1. We can also move the contents of s1 into s2 by invoking the move constructor by explicitly calling std move on s1. In this case, the semantics will have ownership transfer, which means that the characters won't be copied unless the string was in the small buffer. This can mean one of two things. If the string contained inside s1 was small enough to fit into the small buffer, then the characters will have to be copied. This is usually an inexpensive operation because the number of characters is really small. However, if the string inside s1 was too large to fit inside a small buffer, this means that s1 is actually storing a pointer to a dynamically allocated char sequence containing the string. This means that in the case of a move, such as this one over here, well, what will happen is that s1 will give away ownership of that pointer to s2 and no characters will be copied. This kind of ownership transfer only requires a few pointer assignments and is fast independently of the length of the string. So we've seen that std string can be copied and moved, but what about using it in interfaces? What does it mean to take a string as part of a function call? One way you could take a string in an interface is by using the pass by value idiom. In this case, we have a function called setName, which is a member function of person, which takes an std string name parameter by value. Passing by value in this case implies taking ownership and then retaining the passed argument somehow. These kind of arguments are usually referred to as sync arguments. The caller is free to either copy or move a string into setName. Passing by value in this case, compared to a const reference, gives flexibility to the caller to perform a move in the case where that's possible. Here's a possible implementation of setName. In this case, we're just taking name by value and moving it again in an assignment to a data member called _name. This is the pass by value and move idiom, and it's used to take arguments which are going to be retained inside a class or another variable. In this case, the worst possible scenario is that we are going to get a copy as the first argument, and then the copy is going to be moved inside the data member, which will result in one copy and one move. The base case scenario is that the caller will move a string into the parameter and then will move it again. That will result in 2 moves, which is relatively inexpensive. Again, this is called a sync argument because name is retained inside this as we are setting it as part of our data members. Another common way of taking strings in interfaces is by const reference. Imagine this function returning a bool, which tells you whether or not a person has a name of a specific string name. In this case, the intention that the reader gets while looking at the signature is that hasName simply wants to observe the contents of name and not retain them. This is true when an existing std string instance is passed in. In this case, no copies or moves will be made, as all that needs to happen is for the function to look inside the string buffer of the name parameter and compare it to whatever the person has. However, this is unexpectedly expensive when passing in a string literal. If we pass in a const char, we will have to construct a temporary string instance, bind that instance to the reference, and then observe it. Here's an example. Imagine that you already have a string called has0 that contains a name, in this case Bjarne Strustrup, and you want to make sure that some person has the name of has0. In this case, since you already had the string laying around and the type is std string, binding it to a const reference requires no operations at all. So no copies and no moves. However, if you're calling some person hasName with a string literal, like in this example, this will have to create a temporary std string instance from the string literal, which is expensive and could result in a potential dynamical allocation, then bind that temporary std string to the const reference that we're taking as part of the hasName function call, and finally execute the function logic. This is unexpectedly expensive because all we want to do is observe this sequence of characters that's here. We don't need to copy any character or allocate. However, the way we define the function and we define the signature will force this kind of invocation to create a temporary std string. So this is the problem. How can you express, I just want to observe a sequence of char? std string is a known in wrapper, and you should only use it when you want those ownership semantics. If you only want to observe a sequence of char, std string is not the right type to use. This is why a new type, std string view, was introduced in C++17. By using std string view in the signature of hasName, we explicitly tell the reader that our intention is just to observe an existing sequence of char. And also, due to the way this type is defined and works, it will be able to be instantiated with any type of string, not just std string, with minimal overhead.